forward on this so that I can have something to upload later. All right, so we're starting the review. Yvonne has a question. Can you repeat that question to me?
Yes. It's problem with the root.
Okay.
So it's 7x minus 13.
13.
Yes.
And you said that that wasn't a root?
Yes.
Okay.
And then minus 1
Outside of the root, right?
outside the root
Okay.
equals 3x
Equals 3x. Okay.
minus 16.
Minus 16. Okay. Let me just put a little line here because I might have some scratch work. The instructions for this were probably just to solve the radical equation or solve the equation. Or maybe it just said solve. But really, this is a radical equation, so I'll write that this is a radical. Solve the radical equation. Okay. So were you stuck at the very beginning of this, or did you make your way into it? What was the first
No,
step that you?
it's the ending when I have my answer.
Okay.
It was,
Well, but so you got to the end.
yes.
Okay. Why don't you go ahead and walk us through this question? So what would be the first step that I would do here?
To move the number 1 to the other side.
Right, exactly. So we're going to go ahead and add that over like so. Because remember, we want to isolate the radical expression. So by doing this, we can essentially cancel out this 1. Since -1 and +1 give us 0, we've isolated our radical expression, which is this ugly thing. And then this is going to be equal to 3x. And now -16 plus 1 should be -15. Okay, and then what was the next step after that?
Cancel the root.
Yeah. And we canceled the root by acknowledging that we can raise both sides of the equation to the second power, and that'll cancel the root on the left-hand side. So we have 7x minus 13 is equal to this guy, which we probably want to go ahead and write that twice so that we can distribute it out. So we have 7x minus 13, not doing anything to the left-hand side. And then when we distribute this out and then combine like terms, we should be getting 9x squared. And I don't want to skip any steps right now since we're reviewing. So let me go ahead and draw these little arrows. 3 and -15 should be -45x. -15 and 3x should be another -45x. And then 15 and 15 is something like 100 and blah, blah, blah. I don't know. 15 times 15 is, 225. Okay. So we're going to combine like terms. These two become -90. And we have 7x minus 13. Okay. Does anybody have any questions up to this point? I'm sure Yvonne is just waiting for us to get to the end. But I want to give everybody a chance to ask questions if they have questions. Yvonne, is this about what you have at some point?
Yes, I have.
Okay. Does this make sense to everybody else, or is there any confusion?
No.
Okay. Well, now this thing looks like a quadratic equation since we have an x squared term. So what I want to do is move everything over to one side of the equation. And since the x squared's over here, I'm just going to move these two terms to be with their buddies. And I'll go ahead and subtract the 7x and I'll add the 13, just the 13, because I'm trying to cancel them out so I get 0. And if I do that on one side, I have to do the same thing to the other side. So I will subtract 7x and add 13 here. So I have 0 is equal to 9x squared minus 97x. And then this is, that'll be an 8, 3. So plus 238. That doesn't work. Okay. Now, is this the quadratic equation that you ended up with, Yvonne?
Yes.
Okay. Well, when I was working with Kelly in Math World the other day, I said that if you multiply the 9 times the 238 to try to factor this using the AC method, you're going to get a huge number. So you're either going to try to factor this, which is going to be really difficult, or you're going to use the quadratic equation. So I would just go ahead and say, if you multiply these numbers and you get something really huge, let's just go with the quadratic equation. So on to the next page. I have 0 is equal to 9x squared minus 97x plus 238. And what I want to do is label my coefficients. So I have 9 is A, negative 97 is B, and positive 238 is C. And we'll go ahead and throw that into the quadratic formula, which is going to be a negative B, which is negative 97, plus or minus the square root of negative 97 squared minus 4 times A, which is 9, and C, which is 238, all over 2 times 9. So I like to simplify this a little bit at a time. And really, I'll simplify this part first, this part, and then the stuff inside the radical. I'll wait to take the square root because I don't know if this is going to be a negative number. If this is a negative number and I throw the square root around it, I'll get an error in the calculator. So let me just hold off on actually simplifying the radical. So this is 97 plus or minus whatever that guy is. We just throw it to the calculator. That's negative 97 squared. Remember to put it in parentheses. Minus 4 times 9 times 238, which is 841. So we have the square root, because I haven't used the square root, of 841 all over 18. And then we'll see if this is a perfect square, I should be able to take the square root of 841 just to simplify that further. And it turns out that it's just 29. So really this is 97 plus or minus 29 over 18. Now, when you have the answer in this form, what I would say is that these are whole numbers and we can operate with them normally, right? The only thing that would have prevented us from adding or subtracting these two things is that one is a number that's not a radical, and then this one is a radical expression. But since we have just, I'm not sure the exact word for this, but just plain numbers, there's no radical expression, there's no imaginary numbers, we can go ahead and do the addition or the subtraction and then reduce the fraction and see what we get. So what I would say is let's split this up to 97 plus 29 over 18 and 97 minus 29 over 18. And then we can actually do the addition or the subtraction. So 97 plus 29 is 126 over 18. And that will reduce 126 over 18 to just 7. 97 minus 29 is 68 over 18, which reduces to 34 over 9. Is that what you got, Yvonne, or did I make a mistake somewhere?
Yes, I have the same answer, but I use the other system by grouping. So it take me
Oh,
longer.
you did the, okay, yeah.
It take me longer because it
Because
was
when you multiplied 9 times 238, you got a really big number. 9 times 238 would have been that, and then we have to find the factors of that add to make 97, which you would have been looking for a long time, I assume.
yes.
Yeah. Okay. So remember, when you have these solutions, you have to check them to make sure that they work in the original expression. So it might be the case that only one of them works and the other doesn't. So you have to make sure that you check, because on the test, I will put select all the solutions that apply. And if you select both of them, but only one of them works or the other one works, then you'll get points taken off. So just make sure that you check to see which one of these work. And I sort of leave the checking to you guys. Does anybody have any questions?
Well, when I check my answer,
Yeah.
I don't know why both works. I believe maybe I make a mistake somewhere.
Yeah, it's possible that both work. So let me go ahead and check them, right?
Okay.
The original question was the square root of, let me go ahead and write it over here. So the solutions we got are potential solutions. We got x is equal to 7 or 34 over 9. And the original expression is the square root of 7x minus 13. All of that minus 1 is equal to 3x minus 16. So I would just do this in the calculator. Let me see if I can zoom in. And all we're going to do is type the 7 in for x on this side of the expression, and then the 7 in for x on this side of the expression. So it's basically two expressions that we need to compare. So we'll take the square root of 7 times 7 minus 13, and then leave the square root and then subtract 1. So we got 5 there. Then we'll do 3 times 7 minus 16. So 3 times 7 minus 16. And that one equals 5. So since they both came out to the same value, this one works. And then we could do the same thing with the other expression, except we have to be careful with how we type it in because it's a fraction. So it's the square root of 7. Then we're going to put parentheses 34 divided by 9 minus 13. All of that's under the root. Then we're going to subtract 1. We get this ungodly number, which is fine. We just need to compare that to what we get over here. So we'll do 3 times 34 divided by 9 minus 16. And we get a different number, negative 4.6667. So since those are not the same, if we've done everything correctly, which it looks like we have, then we have to throw this one away. Does that make sense?
Yes, I see where was my mistake.
Okay, good. Does anybody have any questions, comments, or concerns?
Yeah, no. When I try to prove which one was correct, I make a mistake.
Yeah.
I see
This one. Yeah, it happens, so you have to be careful. Okay, any questions, comments, or concerns about this problem? Notice that it took me a couple of pages, right? And I did write large because when it comes to math, my philosophy is that you're going to kill trees. Look, I studied ecology and conservation for both of my degrees, so I feel bad about not conserving trees. But the only way you're going to learn math is by getting in there and just having a ton of scratch paper. Okay? So, if you are the kind of student that is trying to work these tests and you're just trying to get, question 1 squeezed into a little box here, question 2's in a little box here, that's just simply not going to work for this test. And it shouldn't have worked for the last test either, right? These require a lot of scratch work. And I need to see that scratch work so I can see what you're thinking as you approach the problems, okay? All right, let's do another question. Does anybody have the next question? Anyone at all?
I don't know if it's like a question we need to like work out, but I told you I do a lot of the like help me solve this to try to learn like different ways and different things to see like what's going on with each like question.
Yeah.
And so I did that with one from the homework. It was 25x to the fourth.
Oh, okay, yeah. Yeah, I know what they did. Anyway, continue.
Okay, it was minus 20x to the second plus 3 equals 0.
Did they do something with U's?
Yeah, they did. Like there was like a lot of letter substitutions, and I mean
Yeah.
it kind of made sense after a really long time, but it was a little, I don't know, it like threw me off. I don't know.
Did anybody else look at the help me solve this or the example problem that they gave you for these?
Yes, it gave me use, but it made me more confused.
Yeah,
Yes.
when I did those, they confused me too.
Okay. Now, what I would say is for these, I could show you the U substitution right now. But I think it's easier for us to just jump into the AC method to solve this. So when you see something like this, the question help is not going to help you because I did not show you guys the U substitution. I feel like for our level, for our purposes, you don't need to know the U substitution. Basically, the U substitution is a way to convert this to a quadratic equation and then solve the quadratic equation. But then you have to do some fancy stuff at the end so that you get all 4 solutions. And I'd rather not put you guys through that. Okay. So we're just going to jump in. We're going to do the AC method, and then that's going to lead us to the 0 factor property. So this is like my workflow for quartic equations. When you work this on the test, I expect to see you apply the AC method, then apply the 0 factor property, and then you're going to solve 2 quadratic equations. And that's basically the 3 major steps for this problem. So just a reminder, the question help for these will not help you. It will probably confuse you more. Do you guys want me to go through this one?
Yes.
Okay.
Yes, please.
Yeah, for sure. So will somebody please tell me what the first step of the AC method is?
The 25 times 3.
Yeah. So
The
we're
A
going to
and
multiply A times C. And the first step for some of you might just be to remember to label these things. A, B, and C. But like once you're comfortable labeling them A, B, C in your head, you're just going to grab A and C and multiply those. So we have 25 times 3, which is equal to 75, right? So we'll look at all the factors of 75 because it's not that big of a number. We have 175. I feel like big numbers are something that's over 100 or over 200. 175, 3, and 25. There's probably a 15 in here somewhere. 5 and 15 maybe. Yeah. And we could probably stop right there since 5 plus 15 will give us the 20 that we need. But remember, you need these two conditions. You need to be able to add these numbers to get negative 20. And you also need to be able to multiply these numbers to get the positive 75. So in this case, we can make them both negative, since that will add to give us a negative and it'll multiply to give us that positive. So both those conditions work out. Is everybody okay with that, or any questions about this logic here? Okay. Well, then we can go ahead and take the middle term and split that up into, and it doesn't matter what order you put this in. I'm going to put negative 5, but put x squared, since this guy is x squared, minus 15 x squared. These two terms should be able to add back to give you that middle term. And we'll just bring this expression down. So again, the only reason we can split this up is because this line right here is equivalent to this line right here. The only difference is that we've taken 1, 2, 3 terms and split the middle one up. So now we have 4 terms and can use the grouping, factoring by grouping. Okay, so what is the greatest common factor for these first 2 terms?
Five x squared.
Yeah, 5x squared. And that should leave us with a 5x squared there minus 1. Is everybody okay with that? Or is there anybody who's not okay with that? Well, on the other side, these two terms have a 3 in common, so I'm going to factor out a negative 3. And that will leave us with a 5x squared minus 1 as well. Does anybody have any questions about that one? Since these match, 5x squared minus 1 is one of our factors. 5x squared minus 3 is another one of our factors. And both of those factors are set equal to 0. So we've completed the AC method portion of this problem. The zero factor property is just the simple fact that we can now say something times something gives us 0. So either this is equal to 0 or this is equal to 0. So we have 5x squared minus 1 is equal to 0, or 5x squared minus 3 is equal to 0. And that's the zero factor property. But now we're going to take these one at a time. This is just a quadratic equation. And the easiest way to solve this kind of quadratic equation is to isolate the x squared. So we'll move the 1 over, and we'll get 5x squared is equal to positive 1. We'll divide by the 5. So I have x squared is equal to 1/5. And then to finally get x by itself, we'll use the square root property, which says we have to square root both sides, leaving us with x is equal to plus or minus the square root of 1/5. And that's 2 of our solutions. Does anybody have any questions about this part?
Yes. Can you do root of 1? Or no?
Here or here?
Right there.
Yeah, you could, but you can't take the square root of 5. So I'll tell you this, I'm gonna leave the answer looking something like this, where it's if it's a fraction and the fraction can't be simplified further, I'm gonna leave it as the square root of 1 over 5. You could, in theory, put this as the square root of 1 over the square root of 5, and it would be 1 over the square root of 5, but I really don't want to complicate your life any further. So we'll just stop with the solution looking like that. Now, if both of the numerator and denominator of the fraction, if they could both be square rooted, then I would expect you to take the square root of that. Like if this was 49 over 25, then we can take the square root of both of those and call it 7 over 5.
It is because in the homework, that's why I have a lot of trouble to answer the correct, even if I kind of close to the correct answers.
Yeah.
Sometimes they were doing that.
So you're saying that in the homework, when they had something like this, plus or minus the square root of 1/5, that they changed this to plus or minus 1 over the square root of 5?
Yeah, I think they do that, and then they put the I. Of course, it's minus the root, and then when I try to answer, it's like, what am I supposed to answer? So yeah, it takes me so long to do the homework, and I have a headache to find out the answers. The correct how they want that we answer.
Yeah.
Because we get the result that you get, but and then the answers that they have more simplified.
I ran
Well-
into the same thing. So even if I had the answer right, I was getting the problem wrong.
I will go into the homework here after class and take a look at that. Last time I checked, they accepted the answer if it looked like this, but they're constantly doing updates to the department is constantly doing updates to those problems. So I'll take a look. It was my understanding that they would accept this. I will tell you that I am going to accept this on the test in Canvas. Or let me put it this way. The answers are multiple choice, right? So you're going to be looking for something that looks like this. I'm not going to trip you up and say that, oh, the answer is actually this.
Okay.
Okay. So if you can get this far, then you're done as far as I'm concerned. There are ways to quote unquote simplify these radical expressions, but really I feel like that's nitpicking that you guys don't have to worry about. That's something that like pre-cal students have to worry about. Okay, but anyway, be that as it may, I'll take a look at that. Let's go ahead and solve this guy. This should be, we move the 3 over to the other side. So we have 5x squared is equal to positive 3. We divide the 5 over to the other side. So we get x squared is equal to 3 over 5. And then when we take the square root of both sides, all you have to do is take the square root of both sides. Remember your plus or minus symbol. And we have the square root of 3 over 5. Again, these are not perfect squares, so we don't have to worry about taking their square roots. So that's your other 2 solutions. Any other questions, comments, or concerns? Definitely going to look at that homework later. Okay. Do you guys have another question for me? Okay. Let's jump in and do this one. Solve the linear inequality. Graph the solution or the solution set on the number line. Write the solution in interval notation. -9 plus 12x minus 1 is greater than or equal to 11x minus 3. And I can tell you so far, there's about 4 questions like this on the test. Okay, so let's take like 5 minutes to try to solve this. And let's make it a race. Whoever's done with it first, just let me know when you're done with it so we can jump in.
I think I'm done.
Okay, cool. Anybody else close to being done? Okay, Kelly, go ahead and walk me through this. What is the first thing that you did when you approached this problem?
I took 11x and moved it over to the other side,
Okay,
which just gave me x.
so you subtracted 11x here.
Mhm.
It's fine. So we have
And then I
9 plus x minus 1 is greater than or equal to -3. Okay.
added my 9 and my 1 to the other side.
Okay, so we can add the 9, add the 1. So we'll add 9 and add the 1. X is greater than or equal to whatever this is.
7.
7. Okay.
And then I drew my number line
Okay.
and I placed a 7 on there and a solid dot with a bracket going And then my arrow went to the right to infinity, positive infinity with a parentheses.
Yeah. So in interval notation, that was 7, comma, infinity with a bracket over here and infinity over here.
Correct.
Okay. Good job. That looks like it. Did anybody get something different?
It's all your help.
Well, it's all your practice, right? I'm not the one who's putting the hours behind My Labs Plus. And ultimately, you guys are the ones that are going to be taking the test. So just make sure that you're putting in the practice, and I know you are. And I say that because I've seen Kelly in in Math World, and I just want to invite everybody to come to Math World when you have free time. If it doesn't work for your schedule, that works too. I'm not trying to shame anybody, but if you need the practice, just reach out to me. Does anybody have any questions about this, or did anybody get something different? Okay, let's take a look at another question.
How many questions are going to be on the test?
20
Okay.
questions. Okay, let's take a look at this one. X plus 2 over 3 is equal to x plus 4 over 7. We need to solve the equation. So I'm sure that we're making this a race. So whoever can solve this, just let me know when you're done. Or if you have any questions right off the bat, feel free to ask. Now's the time to do it.
Is the first thing we do is find the common denominator?
Yes, ma'am.
Okay. And then would I multiply whatever that is to the top of each both?
Yeah, you'll multiply it by each term.
Okay.
When you have that kind of equation, do you have restricted value?
No, so that's a really good question. Restricted values only come when you have a variable in the denominator. Like these denominators are going to be constant values. So it's always going to be 3. It's always going to be 7. So you don't have to worry about dividing by 0.
Okay.
Yeah, good question. Okay, so I'm guessing that we got the LCD by just multiplying 3 times 7, which is 21. Maybe that's one strategy that you used. But then we'll just go ahead and do this. I like to rewrite the equation. And then I like to write in my factor of 21 that I'm multiplying right here and here. And then you just have to remember that when you have a fraction, that's implicit division. So really, you're going to multiply by a 21 and then divide by a 3 later. So here we can say that this is 21 divided by 3, which leaves you with a 7 times whatever was left over, x plus 2. So you sort of get a partial cancellation. Okay, over here, you're going to have 21 divided by 7. So that will partially cancel out to give you a 3. And that we have to still multiply by x plus 4. But now we have an equation that no longer has fractions. Does anybody have any questions about that part?
For the x plus 2 over 3 and then the x plus 4 over 7, could you just cross multiply those?
You could. That is definitely a strategy. Now, I just have a personal vendetta against the phrase cross multiply because students tend to use it for a bunch of different processes. And what I've noticed in my experience is that they confuse all the different ways that you could quote unquote cross multiply. So I prefer not to say, I don't even talk about it, right, in lecture. But if you are comfortable doing that and you notice that that's essentially what you're doing, you're taking this guy, multiplying it up here, taking that guy and multiplying it right there, then that is sort of like cross multiplying. But again, that is, the strategy which shall go unnamed as far as I'm concerned. We can go ahead and distribute out our 7x plus 14 here. We get 3x plus 12, and then we're just back in our ordinary territory solving a linear equation. So we could take this guy over here, take it away, we get 4x. Take this guy over there, subtract that. So that's going to be a -2. Am I on the right track or have I already made a mistake because I'm trying to rush it? Divide by 4 on both
Oh,
sides.
you're good.
And we get -1/2, right? Is that what you guys got? It's totally possible that I made a mistake.
That's what I got.
Okay, cool.
That's what I got.
Now you might be curious about all these arrows that I drew here, but like when you're able to do some things in your head, then this is basically how I see it going down, right? But you don't have to write it out this way. Write it out with all the steps that are clear to you, okay? Okay, let's.
How many of those problems will we have?
These, I think you have 2 or 3 of them, if I'm not mistaken. Two or 3 questions that look like this, where you have to solve a linear equation with some fractions. Okay. Are you guys good to move on, or any more questions about this kind of problem? Okay. So you're going to have problems that look like this. Simplify the rational expression. And the problem might look something like, let's call this 5x minus 5 over x squared minus 5x. And if I'm not mistaken, you have 2 questions like this on the test. Now I can tell you that for one of these questions that I'm putting on the test, I'm going to put a trinomial on the bottom and a trinomial on the top. So you'll have to do the AC method for both of those. So if you don't, or are you feeling rusty on the AC method, just make sure that you go through the proper channels to get help, right? Either my office hours, or some sort of special meeting with me, or Math World, which again is open tomorrow, Friday, Saturday, and then throughout next week. Okay. Let's do one of the harder questions. And it is not lost on me that when I say let's do the harder questions, some of you guys, or maybe a majority of you guys, might be thinking, oh, we haven't done a hard one yet. So let's do something like solve the rational equation. And then, on the test, I like to give you guys hints like find the restricted values or use the LCD to eliminate fractions. Because I know that when you're taking the test and you read the question, maybe you draw a blank, but the hints are there just to remind you that, well, it's basically my way of sort of whispering in your ear gently to guide you along, right? So that you don't get that stage fright at the very beginning. So just know that when you're taking that test and you feel alone, just take a deep breath, read the hint, and remember that I'm right there with you, just, trying to support you, even though you're taking that test on your own. Okay, so we have 3 over x minus 3. We have 7 over x plus 8. And that's equal to 5 over x squared plus 5x minus 24. And you will have, I think it's 2 questions like this on the test. So let's walk through this together instead of trying to do them on our own, right? Does somebody want to tell me what the first step in a problem like this should be?
factorize the x2 plus 5x.
Yeah, we can factorize this. That's a perfect first step. And what I would do is just rewrite the problem as this guy stays the same. This guy stays the same. And then you want to use the AC method to do this. But I also just gave you a problem that had this exact same trinomial in it. So I like to do that where one of the previous problems might have you factor something that's similar to what you will see on the next problem. So if you were too anxious to realize that I do that on the test, then you miss the breadcrumbs that were helping you out on those problems. Okay, so this just factors into x minus 3 and x plus 8. Okay, so we factorized this guy just so that it looks a little bit less intimidating. And so what is the next step that we would take here?
Find the restrictive value.
Yeah,
and
perfect. So what are the restrictive values?
+3 and -8.
Yeah, so we know that x, whatever our solution is here, x cannot be +3 or -8. Does anybody have any questions about that? Is that completely confusing? And you could think about finding those restricted values in a deeper way. You know, when we had more complicated factors on the bottom of these fractions, we said set those equal to 0 and solve that equation, right? So that's always going to be a strategy. But for a simple algebraic factor like this, you could just look at x minus 3 and ask yourself, what's going to make this 0? And if I plugged in a 3 here, that would be 0. So we can't have a 3. And if I plugged in a -8 here, that would make the denominator 0 there. So we can't have -8 either. Okay. Now what's the next step?
The LCD factor.
Yeah. Finding the least common denominator. And which is?
X minus 3 and x plus 8.
Yeah. And since these two factors occur here and here, and then they also occur on the other side of the equal sign, we don't have to write x minus 3 and x minus 3 twice, right? We just have to put them once. Because we'll see when we multiply this LCD by each of the terms, stuff will cancel. So let's take a look at that. It's going to be a lot of writing. So just make sure you have your, your little compression thing for your wrist. Don't want anybody getting carpal tunnel in the middle of the test. You can get it after the test is done. So I gave myself a little bit of space, but with a problem like this, you might take up more of the page, right? And this is exactly a good example of that situation where I said, if you're trying to squeeze a problem like this into a small portion of a single page, then I sort of know that that you don't really know what to write in because you're just trying to pull one over on me, right? Pull a fast one. This requires a lot of writing. Okay, so make sure that you do that. Give yourself the space, the mercy that you need. So I'm going to write those both there. And notice that I'm not sort of writing them. I'm just putting them in. I know I'm multiplying, but I really don't have the space to do it. So this would be fine to just write those factors. As long as I know that you're multiplying and that in the next step you cancel out the proper factors. So for the first term, the x minus 3's cancel out. So you would have 3 times x plus 8 left over. For the second term, the x plus 8's cancel out. So you have plus 7 times x minus 3 left over. And that's equal to just 5 since both of these factors cancel out. So it seemed like a lot of heavy lifting at the very beginning, but this equation that we're left with at the end is actually just a simple linear equation. So we should get 3x plus 24 plus 7x minus 21 is equal to 5. And now we just need to combine like terms, get our x's together, which is in real life never a good situation, but in math it's going to be perfectly fine. We're going to go ahead and put those together, call that 10x. Get these together and call that 3 plus 3 equals 5. Move the 3 over here, so I'm going to subtract it over here, get a 2, and then we'll divide by 10. And so we get 2 over 10, which is 1 over 5. And so that solution should work because it is not one of our restricted values. Did I make a mistake, or are we on board with that? Does anybody have any questions, comments, concerns?
So it's going to be the fraction form and not decimal form every time?
Yep.
Okay.
Any other questions about this problem? You guys want to work another one like this?
Yes.
Sure.
Okay. Let's do it. Solve 3x over x minus 3 minus 4 over x is equal to 12 over x squared minus 3x. These are x's. Does anybody have any questions about where to start?
Is the first step to factor out the x squared minus 3x?
Yeah, we want to factor something out
Okay.
of this.
Okay.
Is that x minus 3 and then x plus 1?
No. It's actually, both of these just have an x in common, right? So you're not using the AC method on this. The AC method is only used on trinomials. So if you have 3 terms, these both have an x in common. So we're just going to factor out a single x, and then we'll have x minus 3 left over. Remember, if you can multiply those back together, they should give you the original expression. Right, so there's a lot of little ways, if you're paying attention, there's a lot of little ways that you can check yourself to know whether you're on the right track or not. So take your time when you're working through these. Don't just rush through them. Okay. Can somebody tell me what the restricted values are?
3.
X cannot be 3. What else can X not be?
1?
Why
Maybe.
1?
I don't know, because there's nothing in front of, the x is just by itself.
Yeah, so what would make this denominator 0? Like what number would you plug into X to make this 0?
0?
Yeah, just 0. And then what is the LCD, or the least common denominator, for this problem?
X and multiply it by x minus 3.
Yeah, I can tell you this. If you factored this correctly, this is usually the LCD. The trouble there is that you have to factor it correctly. So we're going to multiply the LCD into each of these terms. So we'll multiply. Oh, I did not give myself nearly enough space here. We're going to multiply an x here and an x minus 3. We're going to multiply an x here and an x minus 3. We're going to multiply an x here and an x minus 3. Don't worry that I threw extra parentheses around the x. I think that I just got a little bit excited and I started throwing parentheses all over the place. But it's still indicating multiplication. And we're still going to cancel out common factors on this step. Okay. So for the first term, we have these cancel out. Second term, we have the x's cancel out. And then for the third term, we have both of those cancel out. So we have 3x times x, since that's left over. We have minus 4 times x minus 3, and that's equal to just 12. So we can multiply this out. We get 3x squared minus 4x, and this is distributing. So we get a positive 12 here equals 12 there. So this is beginning to look like a quadratic. So we can move this 12 over here, but you'll notice that as soon as you do that, both of the 12s will cancel out. And that's fine. You know, as long as you're doing the right steps, and don't get freaked out just because both of the terms disappear, right? 12 minus 12 is 0. 12 minus 12 is 0. So we don't have to write that because we have these two terms over here. Well, this is looking like it's going to be difficult to use the AC method to factorize it. You could, but I think it looks a little bit strange. But the zero factor property is really nice because if this is factorable, if this expression is factorable, then we can still use the zero factor property. We just might not be able to use the AC method. Looking at this expression, is there something that we can factor out here? Do they have a common factor?
An X?
Yeah, they have an X. So let's factor out the X. And we have 3x minus 4 left over. So since we factored this, the zero factor property says that either this thing is 0 or this thing is 0. So either x is 0 or 3x minus 4 is equal to 0. This first equation is already solved. X is equal to 0, but we know based on our restricted values that x cannot be 0. So we have to throw that one away. And the other equation resolves to just x is equal to 4 over 3, which is not a restricted value, so that's going to be the only solution. Does anybody have any questions about this problem?
I have a question. It's not a problem. This problem is when we had to prove that the answer it works. In which equation we had to do it?
Oh, okay, yeah. Good
Or,
question.
For the test that you're gonna ask, so we prove our answer.
Let's see. So these are the kinds of equations that you have to solve, right? Rational equations, which is the ones we just looked at. So for these rational equations, you check them against the restricted values. So in essence, by me giving you that strategy for finding the restricted values, you don't have to do the work of plugging those solutions into the really monstrous looking equations. You're just checking them against the reference, which is the restricted values. For radical equations, which we'll work one of those here in a second. So you have radical equations, equations with rational exponents. For these, you do have to check by substitution. So you're going to plug your solutions back into the original problem. Then for quartic equations, you will get 4 solutions and they're all valid. So in other words, I'm saying you don't have to check these. But what that means is that you're going to need to be able to identify what a radical equation is just by looking at it. And the same thing with an equation with the rational exponents. But you might make a note to yourself that radical equations are equations that have roots. And equations with rational exponents are equations with fraction exponents. I think that'll be easier to understand. So as soon as you see a root in the problem, just know that at the end of your problem, whenever you get the solutions, you'll have to check them. The same thing if you have an equation and some expression has a fraction for an exponent, then you'll have to check the solution at the end. So I don't know if I've used this analogy in this semester, but a lot of times I think that what we're teaching in math is a lot of rules for sure, but it's really critical thinking and critically applying those rules and also vocabulary. So there's a lot going on here and it's all about problem solving. Like, can I identify and recognize the type of problem that somebody puts before me? And then based on the type of problem that I'm looking at, what are the strategies for solving that? So you might in your notes say like, okay, just like I did with the rational equation, I said, okay, we have a rational equation. It has a bunch of things that look like, I don't know, x plus blah, 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 x plus blah, blah, blah. Just made some stuff up. That when you see something like looks like this, that you're going to look for the restricted values, you're going to look for the LCD, and then you're either going to solve the linear equation or the quadratic equation. But in any case, you'll check the restricted values. I don't know, like some sort of bubble flow chart that tells you, you know, this is the path that I take in solving this particular kind of problem. I think that if you can construct something like this for each of these types of problems that we've been looking at, then you're probably going to be in pretty decent shape.
Thank you.
Yeah. Okay. Well, there's no way that I can cover every single problem that we're going to see, but I think that if we cover 2 more equations, that'll do it for our review. And then if you need more assistance, obviously office hours, we can set up a meeting or Math World. But let's just do 2 more and then let's call it. So let's do something like the square root of 2x plus 15 minus x is equal to 6. And we're going to solve the equation. So can anybody tell me what kind of an equation this is?
Is it a radical equation?
Yeah, absolutely. It's a radical equation because we have a root in it, or a radical expression. So this is what we're dealing with. Does anybody know what the first step is?
Get the square root by itself, so multiply the other half by, make it square, or, parentheses times 2, and get rid of the square root.
Well, we can't get rid of the square root until this is by itself. And right
Right.
now you're subtracting an x.
Oh, so add the x to the other side.
Add the x to the other side, right? So I would say isolate the stuff that's in the square root. So in this particular case, we will add x to both sides. And it doesn't matter how you rewrite this side, these two will cancel out. You'll get 2x plus 15 here is equal to, and then I'm going to feel a lot more natural if I put x plus 6. But again, because we're adding, it doesn't matter what order you add in. 2 plus 3 is equal to 3 plus 2. So 6 plus x is the same thing as x plus 6. I just like the variable to come first. Okay, but now, as Kelly suggested before, once you've isolated the square root stuff, then you will square both sides. And what I mean by that is we'll take this stuff and square it, and we'll take this stuff and square it. So square that, square that. This cancels here, so we get 2x plus 15. And that's equal to x plus 6 times x plus 6. Okay, does anybody have any questions up to this point? Well, now we're just going to simplify both sides, and there's nothing to simplify over here. We can't combine these terms. So we'll look at this, and remember, x plus 6 squared is just x plus 6 times itself. So we have to distribute that out, and we get x squared plus 6x plus another 6x plus 36. Everything is really messy right now, starting to look like a quadratic, but since it's so messy, let's go ahead and combine these guys, call that plus 12x plus 36. And then, since this is a quadratic, we'll have to solve the quadratic equation. So we'll move everything over to this side. So we get 0 is equal to x squared plus 10x. And then I have no idea what that is, and nor do I have the patience to actually subtract that in my head. So I'm just going to use the calculator. 21, positive 21. And then maybe if you need a tiny little flow chart to remind you how to solve quadratic equations, remember you have 3 strategies, but only 2 of them are going to work here. And that's the AC method and then the 0 factor property, or the quadratic formula. But if you were to factor this, you would get x plus 7 and x plus 3. Okay, and I took a little pause to give you a chance to factor that trinomial if you needed to. And then some of you might be comfortable enough with the zero factor property to know that when we set this equal to 0 and set that equal to 0 and solve them, you'll just get that x is either equal to -7 or -3. Does anybody have any questions? Or are we still working on that? Well, now we just need to check these solutions to see if they work. So I'll plug them back into the original problem, which I realize I've written all over. Let's go ahead and I'm going to plug -7, one of my solutions, into the x's and see if I get 6. Okay, so the square root of 2 times -7 plus 15 minus -7, and looks like that's equal to 8. So I have to throw that away. -7 did not work. Well, then I'll do the same thing with -3. So I have 2 times -3 plus 15 all over this, all under the square root minus -3. And I should be getting 6. Well, that one worked. So I only have one solution here. Does anybody have any questions, comments, or concerns about this problem? Okay, one more problem, and then we'll call it a day. Make sure that when you're working on this, that you space out your practicing as you lead up to the test, because even I feel it, a little bit of exhaustion as you work a lot of these equations, because they're so long. There's a lot of steps in the process. So make sure that, you know, if you're working on the 40 question review and you have like 5 days or so, just like do 5, maybe a few more than that questions a day, and then come back to it a little later on that day, or come back to it a little bit the next day, right? But break it up. If you do it all in one go, then it's going to be like, oh, I just crammed this and I'm not sure what's going to stick. So just make sure you're taking care of yourself, take lots of breaks, go outside, come back in. Let's do this one. X squared minus 17 raised to the 1/3 power is equal to 4. We're going to solve the equation. Can anybody tell me what kind of equation this is?
Rational exponents.
Yeah, this one's an equation with rational exponents. Okay. Does anybody know what the first step is here?
Cancel the 1/3.
Yeah. And how would we go about doing that?
Multiply for its reciprocal.
Yes. So what I would say for this, in order to multiply 1/3 times its reciprocal, we're going to have to raise both sides to the reciprocal power. Okay, so what I would say is like the first step is to isolate the thing that has the rational exponent, which it's already isolated here. And then I would say use the reciprocal power. Which means that this side of the equation is going to be, let's say that this would be m over n now. And you're going to do that to both sides of the equation. In this case, the reciprocal of 1/3 is just 3. So I would just put brackets around here, raise that to the 3rd power, put brackets around here, raise that to the 3rd power. And that is just because a power raised to a power, you multiply those powers, but since these are reciprocals, they'll cancel out, leaving you with x squared minus 17 is equal to 4 to the 3rd power, which you can simplify in the calculator. 64. Does anybody have any questions up to that point? Well, now we're just trying to solve the equation, and in this case, we have a quadratic equation. And I think that the easiest way to solve the quadratic equation here is that we can get the x squared by itself by adding 17 to both sides. These guys will cancel. And this will be, I have no idea. 64 plus 17. It's about that time where the brain fog sorts of sets in. 81 looks right to me. And then in this particular form of a quadratic equation, I can use the square root property, which is you take the square root of both sides, and then you get x is equal to plus or minus the square root of whatever that other side is. So whenever you use the square root property, don't forget the plus or minus. So you get x is equal to plus or minus. The square root of 81 would just be 9. So we have two solutions, 9 and -9. And we had to check to see which one of those works. Or both of them work. So I would have parentheses, +9 squared. And just to be safe, you want to use parentheses because we have parentheses on the outside. And then when we're plugging in a number, so I'm going to do another parentheses, 9 squared, like so, minus 17, close the parentheses like that. So anytime I plug in a number, that number needs to be in its own set of parentheses. I'm going to raise that to the 1/3 power, so that's a 1 divided by 3, and I'm going to see if I get 4. So sure enough, positive 9 worked, so that solution works. We'll do the same thing here, except this time I'm going to substitute in a negative 9. So I have parentheses and then parentheses negative 9 squared minus 17 raised to the 1/3 power, and see if that gives me 4. Well, yeah, so both of them work. Okay, does anybody have any questions about that? Okay, guys. Well, I think that there's limited utility in you watching me do problems, which is why I did want to go over those with you just to see if you guys had questions so you could see them worked, just the mechanical process of running through the problem. You noticed probably in the lead up to today and in today that these problems have a lot of steps. So the only way that you're going to get this stuff down is by making yourself one of those little mental maps and getting the practice in. Okay. So just make sure that you've spaced out that practicing, because cognitive psychologists have determined that as far as studying is concerned, if you spread it out and you have distributed studying, that is so much better for retaining the knowledge compared to cramming it all into one ridiculous session, right? Plus, you're going to burn yourself out. Okay. And we don't want to do that. So I'm going to be continuing to work on the test and importing it to Canvas, since that's such a long and arduous process for me. It will be up later today. I'll send you a message and remind to say that it's up, but that will be up through next Friday. Okay. So if you still need to get caught up on homework, if you give yourself enough time to work on the review questions in MyLabs Plus, and just be checking in with me to make sure that you're where you need to be. Okay. If you need help or assistance, you can always send me a screenshot. We can schedule a meeting if you want some one-on-one tutoring, or you can just drop into my Math World hours. Okay. So I will be available today in office hours, tomorrow and Friday in Math World. But if you need some help over the weekend and we can work something out between the two of us, then we'll see about doing that. Okay. But you have to send me a message so that we can do that, get some one-on-one tutoring going. Okay. One last thing that's not related to test number 3. Just remember that if you are still trying to take the retake for test number 2, that is due on Friday. Okay. I'll send a message out on Friday that it says, hey, today's your last shot to take the retake for test 2. So if you do want to retake that, it's completely optional. If you don't, it's cool. Your grade is just going to be where it is. Okay. Does anybody have any other questions for me?
Yes, sir. So we have 2 tests, right? Well, this the retake and then the one that's due next week.
Well, I mean, we already took, the retake. We already took test 2, so that's not really a test, right? That's just an optional thing if you want to make up your grade, or
Okay.
pick it up. So,
But we
some
do
of you
have
may
one
be
due next
focusing on that, but make sure you give yourself enough time when you're done with that to, study for test number 3, because on Monday we're starting new material.
Okay.
I would say my recommendation is that if you are a little bit behind, it's okay. Just give yourself enough time to catch up. But if you really want to feel comfortable with the pace of the class, you should be finishing up or getting prepared to take test 3 by the end of the weekend. Like if that's where you are, then you're in good shape as far as like the material. if you're further behind than that, that's okay too. Just make sure you reach out and communicate with me so that we can do what we need to do to get you caught up. Okay, because there's not much time left in the semester.
Okay, yeah. It's because I want to retake test too.
Yeah, for sure.
So I'm gonna probably do that tomorrow night or maybe tonight.
Okay, yeah. Just let
it's-
me know if you run into any issues, just send me a message.
Okay, well, thank you, sir.
Cool. Any other questions? Okay. Well, you guys enjoy the rest of your day. Make sure that you take lots of breaks when you're studying. And if you have trouble, just reach out to me, okay?
Thank you.
I'll see you guys next
Thank
week.
you.
I'm sorry, I have a question.
Yeah.